Guys, so today we're going to be learning about the laws or properties of exponents. So this is going to be page 31 in your notebooks. And like I said, we're talking about the properties of exponents. So there are technically six properties of exponents that we're going to learn about. You use these in Math 2 and Math 3 as well, so they're super important. A lot of you have probably seen them before in middle school. So before we even can start with properties of exponents, we have to make sure we remember what an exponent is. So just to review, an exponent is an index of a number that tells us how many times we are multiplying a number by itself. Okay, so that is what an exponent is. We will review with some vocabulary. So I'm going to give you guys just an example. If we have 3x to the 7th, okay, the exponent is the index, so the 7. Index means it's above, okay? So this 7 is the exponent. It can also be called a power though. So if you see the word power, we're talking about an exponent, all right? The x in this expression, remember this is an expression, not an equation, because an equation has an equal sign, and do y'all see an equal sign? No. So the x right here is called the base. That is what is being raised to the 7, okay? The 3 has nothing to do with the 7. The x is what's being raised to the 7. The 3, I always like to box off like it's by itself, is just the coefficient. Okay, so that's your vocabulary review. We have talked about a coefficient and a base before. The only new one is exponent, but you guys do know what an exponent is from middle school. So now we're going to go ahead and get into our properties. I'm going to try to keep this short and sweet. So property number 1 is going to be the product rule. All right, so the word product, hopefully we all remember this, means that we are multiplying, right? All right, so this is what the product rule says. When multiplying two terms, it can also be more, with the same bases, and we'll talk about what that means in a minute, okay? When multiplying two terms or more with the same bases, you can add the exponents. All right, so y'all know me, you know I love to show you why stuff works. So I am going to show you why this works, okay? So let's say we have, let's say we have x to the 3rd times x squared, okay? A lot of people just like to assume, because you guys see 3 times 2 and you're like, oh, it's 6. But you have to remember that this 3 and this 2, they're indexes. They're not numbers. An exponent is not a regular number, okay? It is raised. It's an index. So it has completely different rules. So for x cubed times x squared, we need to talk about what this means. So x cubed means we have how many x's times itself? 3, right? X cubed means there are 3 x's multiplying by themselves. So x appears 3 times. X squared means there are 2 x's multiplying by themselves. So the base x appears 2 times. So how many x's did I just draw out? 5. And the reason that this works is because 3 x's adding on 2 more to go with them will equal 5. So x to the third times x squared is actually x to the fifth. Now, listen to the language. Don't say x3 because that would be this. Okay? That's not what we wrote. So this is x to the third, or x cubed, times x to the second, or x squared, equals x to the fifth. Don't say x3, x2, x5. I'm going to get y'all for that. You know I'm big on vocabulary, okay? So we just saw how it works, where when we're multiplying, we're going to add the exponents. That's your biggest thing. So when you're multiplying and they have the same bases, you can add the exponents. So let's do a couple of examples, okay? All right, example 1. Let's do a cubed times a to the 8th times a to the 4th. So I'm multiplying. That's the first thing we need to check. Do each of these terms, because remember they're each their own individual thing, have the same base? So do all of them have a base of a? Yep, they all have a base of a. So since I'm multiplying and all the bases are the same, I can add the exponents. So what is 3 plus 8 plus 4? 3 plus 8 is 11. 11 plus 4 is 15. All right? So all we're doing is adding the exponents as long as the bases are the same. All right? So let's do another one. Let's do example 2. Let's try x squared y times x cubed y to the 4th. Okay? So, first thing, are we multiplying? So even though there's no multiplication dot, you guys know if 2 parentheses are touching, that means to multiply. So we are multiplying here. So the next thing we have to check are, do they have the same bases? Are the bases the same? So this one's a little tricky because I gave you x's, multiplying by x's, but I also gave you y's multiplying with y's. Okay? Which ones do you think we're going to combine together? Are we going to combine x's and y's? No, that wouldn't make any sense, right? Remember, this is just like combining like terms, where the x's have to go with the x's and the y's have to go with the y's. They have to be the same base, okay? So there are 2 x's that have the same base, which means I can add the exponents. So this will be x and then 2 plus 3. X raised to the 2 plus 3, which is going to give us x to the 5th. And then we also have y. Now, this one doesn't have an exponent. So what do you guys think the exponent is? And understood what? Very good. This y has an understood 1 as its exponent. So 1 plus 4, which is also 5. And then I squished them together because we are multiplying. So you can't combine x times y, so you just write xy, okay? So this is just x to the 5th, y to the 5th. Sound good? All right, let's do maybe 2 more. Example 3. All right, so this one looks a little bit different. What's different with this one is I gave you guys coefficients with the c's, okay? Now, does this rule say anything about our coefficients? No, because you guys know how to multiply 2 numbers. Remember, a coefficient is just the number out front. So these numbers out front, this 2 and this 3, you're just going to multiply. So what is 2 times 3? Good, that's going to be 6. But now we're multiplying. My bases are the same, so I'm going to bring down my base. and I add the exponents. So do not put 12 here. This is 4 plus 3, which is 7. So if I listed this out, this would be 4 C's put together with 3 more C's. That does not make 12, that makes 7 C's total, okay? So we can multiply coefficients, but we're gonna add the exponents. Coefficients are just plain numbers, so you guys know if it says 2 times 3 that you should get 6. All right, let's do one more. I'm gonna put it right here, and I want you guys to try it first without me. So yes, I'm gonna sit here on this video being quiet because I want you to try it, okay? 9 x to the 6th, y to the 7th, times 10 x to the 5th, y to the 3rd. All right, I want you to try this one. I'm going to give you like a minute, okay? All right, it's been a minute, so let's look at this one. So first thing I see, 2 parentheses touching, that means we're multiplying. So you guys should notice that the 9 and the 10 are just plain numbers out front. They're coefficients. So 9 times 10 is going to give me 90 for the actual number out front, the coefficients, okay? Now we need to go look at our variables and see what's the same so we know what to add. So this x to the 6th is multiplying by x to the 5th. If we're multiplying and the bases are the same, meaning they both say x, then we can add the 2 exponents. So 6 plus 5 gives us 11. All right. Now, for the next one, we have y to the 7th times y to the 3rd. They both have a base of y, so I'm going to bring that base down. And 7 plus 3, because my rule says to add the exponents, gives us 10. So your final answer here should be 90 x to the 11th